you guys, this is Hodge. I hope you guys are doing good. I'm making this video to help us practice our transformations essential skill if it's something that you're not currently passing. So copy down this problem. Remember to always pause the video when I suggest it to you, because often after when I say pause, I'm just gonna pop up my answers. So if you haven't had a chance to do it on your own, it might ruin it for you. So just make sure you're following along and pause the video and try things on your own when you get a chance. So go ahead and copy down this problem. So the first thing I notice is that it's not in our graphing form. G of x needs to equal negative 3f. This x needs to be a single positive x. So we need to factor out the 1/2. When I divide by 1/2, negative 1 divided by 1/2 is the same thing as multiplying by 2, so minus 2. Another way you can look at that, if I redistributed that that positive 1/2 to that negative 2, I would get negative 1, so I know I did it right. Then I went ahead and I drew f of x for you, which is that random graph up above, and I put the points in the table. We need to find our new points. So remember, we have x over b plus c and ay plus b, but remember the c is always opposite of whatever it was in the equation. So since b is a half, if I do x divided by a half, that's really just 2x. And since it says minus 2 in parentheses, I'm going to do plus 2. ay plus d, negative 3y plus 2. So I take the x value in the left column, and I do 2 times negative 3, which is negative 6, plus 2, which is negative 4. And why don't you go ahead and do that to all the x's. Work your way down, transform all the x values. Pause the video. Okay, this is what I got for all my x's. Then I'm going to transform the y values. So take each y value and multiply it by negative 3, and then add 2. This y value times negative 3 plus 2, all the way down. If you haven't yet, pause the video and finish your y's. Okay, there are my y values. So we're kind of prioritizing here. Most of you guys do okay on these problems. When I grade it, you get 1 point for getting these x's correct, 1 point for getting these y's correct. You do get a point for making your new sketch, but I don't want to waste our time plotting points together. I'm sure you can plot those points on your own. And then you get a point for every transformation. So notice I have my transformation answer blank over here on the side. Why don't you work through, when I do it, I do go from left to right, so the negative sign would be the first transformation I'm going to do. Why don't you go through and see if you can name all the transformations for our graph. Okay, so there are mine. Working from left to right, the negative sign reflects it vertically. The 3 stretches it vertically. 1/2, I know it's kind of weird because it seems like it's a small number, but when b is a small number, it actually stretches it horizontally. Minus 2 moves it right 2, and plus 2 moves it up 2. Again, most of you have this down. I'm just going to be honest with you. For most of you, it's the log or the exponent problems that we're struggling with. So let's copy this exponent problem down, and then we'll work through this together. Okay, for our exponent problem, not in graphing form yet, take a second and change it to graphing form if you haven't yet. Factor the 2 out. Then I see that we are doing a 3 to the x problem. Our parent graph is 3 to the x, so over here, 3 to the x. Okay, when it's exponents, x is negative 2 to positive 2. It's logarithms where we do y's, but for exponents, you keep x's negative 2 to positive 2. You're going to plug in x values. Right now, I'm just doing it for 3 to the x. So 3 to the negative 2 is 1 over 9. Negative exponents, 1 over 1/3, 1, 3, 9. That was just using the equation right above it in green. Now for our new graph, x over b plus c. So x over 2, because the b value is 2, minus 2 because it's opposite, and then negative 2y minus 1. Take a second and see if you can find the x values. Pause your video and then I'll show you my x values. There are the x values I got, and then if you haven't yet, go ahead and find your y values. Pause your video and find your y values. Okay, there are my y values. So let's work on sketching this. So set up some axes. Let's see, everything's negative, so leave a lot of space in the negative zone of your axes. -3, mine's on graph paper, so I'm just using the graph paper that you see. Oh, in fact, before I start graphing these points, see how small my, well, not small, but -1 2/3, -1 2/9, they're getting closer and closer to -1. That's because the asymptote is y equals -1. The asymptote for exponentials is that constant d at the end, a y value of -1. You have to include it in your sketch to get full credit. A dotted line at -1. Now I'll be able to plot my points. Go ahead and plot your points. Pause it and plot your points. Okay, so I'm not sure if you can see them, but my points are plotted, and I'm not even hitting those points. You guys get the idea. I try my hardest to hit those points. Curves along the asymptote. I'm sure you could do a better job on paper than I'm currently doing on the iPad. Okay, x-intercept. So this is why I sketch it before I start answering these questions. Clearly it doesn't have an x-intercept because your graph is down below and it's not allowed to cross that y equals -1 line, so this does not exist. Y-intercept, we'll come back to that one. Domain, the bottom arrow is going down to negative, sorry, that's for range. Both the arrows are going left and right forever, so the domain is all real numbers. Range, the bottom arrow is going down to -infinity. The highest it's allowed to get is really, really close to -1, so -1 parenthesis. Okay, y-intercept. For any graph, any equation, in any grade level, to find the y-intercept, you make x equals 0. So in my equation, I'm just going to do y equals. And I like to do it in the original one before we factored things out, because as soon as I make that 0, and in fact normally I wouldn't write it, I would just jump to this step, -2 times 3 to the 4th will be all that's left, right? Because 2 times 0 is 0. Let's see how messy this comes out to be. -2 times 3 to the 4th is the biggest one we make you memorize. I know that's 81. 2 times 81 is -162. So my y-intercept is 0, -163 if I did my math right. We'll look this over and then we'll try the one on the next page. So this was an exponent problem. Again, I want you guys to start remembering when it's an exponent problem, the x's are -2 to 2. When it's an exponent problem, the constant d is your asymptote. Y equals, some of you guys are getting those confused also. So let's see what changes when we do a log problem on the next page. Take a second and copy this log problem down. Pause the video so you don't fall behind. Go ahead and put it in graphing form because it's not quite in graphing form yet. Pause the video. As I was going to put this in graphing form, I realized I didn't give you a base. So change the problem, well, not change the problem, but insert that base that it should have been written there from the beginning. That's my fault. So this is 2 log base 2. Factor the 1/2 out. Make sure it looks like a 1/2. X plus, if this is 2, then it would redistribute to be correct. Okay, logarithms. For logarithms, we're doing log 2 of x. You plug the y values in as -2 to +2. Because I can't do this in my head as a log problem, so we change it to an exponent problem. So if that's confusing you, log 2 of x equals y. We rewrite this as 2 to the y equals x, and this is the equation that I'm plugging these y values into, and it's very similar to the one we just did on the other page. 2 to the -2 is 1/4. 2 to the -1 is 1/2. Anything to the zeros, 1, 2, and 4. See if you can figure out what you're going to do to get your new x and y points. What's the equation that I'm going to write up here? Pause the video and see. Okay, did you get the same equation as me? So x over b, x divided by a half, is really just 2x minus 2 because it's opposite, and then 2y minus 3. See if you can fill in this whole table. See if you can carefully do all that math for the x's and the y's correctly. Pause the video. Okay, check your points with mine. Axes, I've got mostly negative y's. It's kind of right in the middle, I'd say. So set up some axes. The graph is important for these ones. You're required to graph the ones from the very first slide also, but I just have a little more faith that you guys can do that on your own. I don't need to plot those with you. One of the most important things I want to show is the asymptote. Asymptote from logarithms comes from c. So it says x plus 2. So I'm about to graph an equation at x equals negative 2. So straight up and down through negative 2, and I'm going to add it to my answer blank also. X equals negative 2. It changes. Logs are different than exponents. Well, they're inverses of exponents. So if it's x equals for logs, it's y equals for exponents. Then see if you can plot the points. Try to carefully plot the points. Pause the video. And there are my points, and I try to slowly draw in the curve, hugging the asymptote. Okay, see what part of the bottom answer blanks you can fill in. Y-intercept looks pretty easy. Domain and range should be pretty easy. The only one we have to work on together is x-intercept. So pause the video. When you press play, I'm going to have every answer except for x-intercept on my screen. Okay, there they are. Y-intercept was 0, negative 3. Asymptote we did together already. Domain from negative 2 with a parenthesis to infinity. Range is all real numbers. X-intercept will take some math. No matter what grade, no matter how complicated the equation, to find the x-intercept, it's always y equals 0 or equation equals 0. I'm going to use the non-graphing form to help me out. I don't even know if I left enough space for myself there, so I might start not showing every step. Show the steps on your papers to help yourselves out, but I would add 3, and then I would divide by 2, so I'm going to jump right to that. Equals. This one's really going to be a mess. Okay. Then I would make it an exponent problem. 2 to the 3 halves. And I don't expect you to do that. Just leave it as 2 to the 3 halves. Equals everything left in the parentheses. The whole time you're going to leave that as 2 to the 3 halves, and you're just going to put your math around it. So go ahead and finish it if you have room, and I'm going to write my answer on my x-intercept. So it's going to be 2 times 2 to the 3 halves minus 1, comma 0. It won't be that messy on any assessment we ever give you guys, but I minused 1, and then my last step was to multiply that whole thing by 2. Another way you could have written this could have been 2 times 2 to the 3 halves. You cannot actually multiply the 2 without an exponent with the 2 that has an exponent, and then minus 2, comma 0. Those of you that want to get real crazy, technically this is 2 to the 1 times 2 to the 3 halves. So you could add those together and get 2 to the 5 halves minus 2, comma 0. Again, I just made this problem up. They will not be that complicated, but make sure you understand the general idea. X-intercepts, you make y equals 0, and you do the math. So hopefully this helps you guys prepare a little more for your transformations essential skill. Don't forget about all the resources available on Schoology, and keep practicing. I hope you guys are doing good.